my name's Brittany Jordan, and this is my Geology of the Ozarks project. The first picture I have is a picture of dolomite that I found at the Springfield Nature Center. And dolomite is a sedimentary rock, which means that it goes through the process of liquefaction, which is just the hardening of loose earth and gravel and fragments that all get put together into one rock. And this dolomite is actually more of a unique sedimentary rock because it's not formed on the surface of the earth. It actually goes through a complete mineralogical change before it is deposited, which makes it hard to form. And it's usually light colored, and the condensed minerals that make it up are calcium and magnesium carbonate. Okay. The next picture I have, I titled "The Hills Are Alive," which is one of the many hills in the Ozarks. And the hills are created from the movement of the earth below us. Scientists call this plate tectonics, and under the surface of the earth there are a bunch of plates and fault lines that are constantly shifting and moving. This is actually called a deformation, and it is specifically faulting deformation. It's when the fault lines push together and like one goes up while the other one goes down. And this is a convergent fault. And this was taken at the Springfield Nature Center. The next picture is chert. You can see that. And chert is one of the most abundant rocks found in Missouri, and it's usually found near waterbeds and rivers. And it's a sedimentary rock that is made of microcrystalline silicon dioxide, and it breaks with a conchoidal fracture, which creates a rounded surface, and it's actually very sharp. They used to use it for like arrowheads and tools, and also for flint. And it's been used for many centuries. And the abundance of chert we found in this area was because of the river and the lake that's nearby. The next picture is of limestone, and there's a ton of limestone everywhere. This is a biochemical sedimentary rock, and it had evidence of weathering on it that was visible from the green and brown coloring growths on the outside of it. Limestone is formed by calcium carbonate, and it is made of sediment and fragments of organisms. This makes the connection of the organisms and the carbonate found on the rock by the weathering that goes there. And this sample of limestone in the picture is more of the chalk form because of its fine-grained texture and microscopic fossils. Okay, the next one is siltstone. You can see there, I got creative with my pictures. This sample of siltstone really shows the difference of layers between, and like had different sizes of fossils in each layer. And it was tan brown color. And this is a sedimentary rock because it is composed of fossils and sediment grains. It is called siltstone because of the silt side, its weathering and grains. And this sample looked like it had some clay in it as well. It was pretty like thick. And it was one of my favorite rocks that we found because of the texture and color. Okay, the next picture is rolling on the river, and this was a picture we took of the riverbed. We couldn't really get us in it. And it is the river feeding into Lake Springfield, located at the Springfield Nature Center. The riverbed was extremely muddy, and the rocks were very round. And the roundness occurs because of the constant flow of water that erodes the rock into a smooth shape. This is called hydraulic action, which is the force of water moving against the rocks, causing erosion. And the rocks shown are most likely sedimentary since it's in an environment of water. And this is me in my lab book standing next to the river that we were over. Okay, the next picture is I titled Earth Be Gone, and it's the erosion near a smaller stream that was feeding off of the river. And it's also at the Springfield Nature Center, and it's displaying the erosion that occurs on the side of a riverbed or body of water. The water in this small stream is a force against the soil, which along the edge of the stream, and the soil flows. As the river flows, pieces of the soil like break off, and rocks break off, and they're deposited down the river, and then it just continues, like the rocks continue to move. And each time they move, they get smaller and more eroded as they are rolling down the river. Okay, the next picture was on Lone Pine Road near Sequoia Park, and it's a picture of a road cut. And the thing that's unique about road cuts is that they show exposed rock that would normally be hidden in the hills, and so we wouldn't be able to see them. And because the rock is exposed, you can really see the cleavage. And road cuts have given geologists the chance to study the different rocks in each of the regions of the United States. So we can kind of know a lot of Missouri has limestone road cuts. This tells much about the history of the earth. For example, the road cut shows that Missouri has limestone in some of the hills. According to the geologic formation of Missouri, this sedimentary rock was formed when the sea levels were high. The next one is the rock quarry, right near Lone Pine Road. And this specific rock quarry was the Conco rock quarry, and they make concrete mixes. And the way that it works, I had to look it up because I didn't understand. They just like bash up the rocks basically into dust, and that creates concrete mixes. And they were talking about how you have to be really careful about consideration for the environment around and making sure that it's the best location. And they have to hire geologists to decide that that's the best location. And they mine the landscape, and then they drill or blast the rock to obtain it from the earth. And quarries can be destructive to an environment if they aren't considerate of the communities and the wildlife around. The next picture is a cave, and this is at Sequoia Park in Springfield. And this is a very tall cave, much taller than I am. And the study of caves is actually called speleology, which contains actual geology, biology, hydrology, and archaeology are all combined in that. And then I believe that this is a solution cave, which means that it was formed from the ground, water around it, which dissolves the rock. Also because it was made out of limestone, and most solution caves are made out of limestone. The formation of these caves are very unique and have baffled mankind. The best explanation that I have found is that groundwater dissolves carbonate rocks and creates a cavity below the water table. The water table is the place where water is stored in the ground 24/7 and is also known as the zone of saturation. Then it is said that the water table drops, creating the cavity to be in the unsaturated zone, which is where the air comes in, and the air causes the calcium to make the calcium drifts in the caves. And here's the cave right next to that, with the spring that I'm about to explain. And I titled this Spring into Geology. And this is also the spring at Sequoia Park. And this spring specifically goes back 500 feet into the cave. And I learned that Sequoia literally means many springs, so it's kind of neat to learn the name of the park is because of this spring. And the spring may be the leading cause of the formation of the caves surrounding the water, just like I had mentioned. Water has such a powerful force in the geologic formation of rock and land. Springs occur when the water table meets the surface of the earth, and they are the result of an aquifer that is filled up to the point that it reaches the surface. Springs in Missouri are found near limestone and dolomite, and because this spring is large and has a strong flow, it tells us that the water pressure from the aquifer is relatively strong, and the cave and basin allow for more water to flow into the area. Okay, the next picture I titled Crack Kills, and this is a crack in a cave, the same cave that we've been looking at Sequoia Park. And I just wanted to explain more about the crack. And it could be caused by plate tectonics and the moving of the earth and shifting and pulling away. It could also, it is also considered cleavage, which is defined as the way a rock breaks. And this crack specifically, because it's not straight, it's considered an imperfect cleavage. The next picture is sandstone. We found this at the beginning of the trail at Springfield Nature Center. And sandstone is also a sedimentary rock. And this is the common type of rock to see in the area because of the lake nearby, which I said before. And sandstone is contained as sand and may have some fossils in it. And this sample is brown and has a lot of little indents from the way the sediment went into liquefaction. And it is a detrital or siliciclastic formed rock. Alright. And the next picture is at Kraplinger Mills. My friend Danielle lives there, and it's near Stockton, Missouri. And it's actually a water mill, and then they have like this. This is a picture of the waterfall around the mill. And I just wanted to explain, a water mill works by having a wheel that is turned by the force of the water in the river, and they convert that into energy. And the water really doesn't, or the water mill doesn't really affect the environment in a big way because it's just going with the flow of the river, and so it's not really going to do anything outside of the natural erosion that already occurs from the river. And the last picture I titled The Great Climb because me and Danielle took a great climb and almost fell quite a few times to this rock. We thought it was really neat, just how it was like coming out of the earth, and we had to go see it. This is an example of a rock that is exposed without a road cut, which I think is really neat. And the rock jets out of the earth as a deposit, and the exposure of the rock could be caused by years of erosion from groundwater running down the hill. So this is my project. I hope you guys enjoyed it. Thank you.